Good day, I'm Dr. T and welcome to my whiteboard. Today we'll be looking at determining empirical and molecular formulas if you know the percent composition and molar mass of your compound of interest. The reason we would do this is that if you do have an unknown compound, relatively easy, especially back in the day when there were less techniques than we have now. One way of identifying it would be to figure out the percent abundance of each element in the compound. Maybe use other techniques to get the molar mass, and from that you could at least get the molecular formula. So for starters, we're going to find the empirical formula, and for that we're going to need the percent abundance of each compound. So in this case, I've got three elements in my compound, sodium, sulfur, and oxygen. And so I've got them in percent form. So I know it's 19.3% sodium, 26.9% sulfur, and 53.8% oxygen. Now, I can't work with percents directly, so instead I'm going to just assume that I have 100 grams. Or maybe pretend I have 100 grams is a better way of saying this. So if I were to have 100 grams, then that means I would have 19.3 grams of sodium, 26.9 grams of sulfur, and 53.8 grams of oxygen. Or, in other words, 0.84 moles of oxygen, 0.84 moles of sulfur. Hey, look, they're the same. And 3.36 moles of oxygen. Okay, so now what I want to do is figure out some ratios, because remember, an empirical formula is a ratio. So I'm going to find the smallest one. Oh, look, it's a tie, so I'll pick one of the two. And I will divide each one by the smallest. Well, 0.84 divided by 0.84 is 1. 0.84 divided by 0.84 is, 1. 3.36 divided by 0.84 is, 4. Okay, that says I have a ratio of 1 to 1 to 4. Yay. My empirical formula then would be NaSO4. That is my empirical formula. And if that's all I'm looking for, I'm done. But I'm not done because I want more. Now, I know that the formula weight of my compound is 238 grams per mole. I can calculate the formula weight of this, and I find that's 119. These two don't match. So I'm going to figure out a ratio. Okay, I do that, and I get a ratio of 2. That means that I have 2 empirical formulas in my molecular formula. I times everybody by 2. So my molecular formula will be Na2S2O8. Before we wrap up, I want to talk about another example to show a couple of quirks when doing empirical formulas. Now, for starters, I've got 4 different compounds here instead of the original 3 on the previous question. Now, in this case, once again, I've set things up exactly the same way. I've got my percent. I'm not going to find molecular formulas, so I'm not going to worry about that part. I've done assuming or pretending 100 grams. I found moles. I picked the lowest one. In this case, that's the nitrogen, so the 0.68 moles. I divided everybody by that. And here's where a couple of things happen that get interesting. For starters, you'll note that I get 8.97. This is awfully close to 9. Sometimes, just due to rounding and the location of your sig figs, you can have small gaps and small differences that you just go ahead and round to the nearest whole number. But keep in mind, we're talking small jumps, not large ones. And down here, I actually have a large jump. This is 2.5. This is not something you're going to round. This is probably saying that you don't have a 1 in your empirical formula. Instead, I'm going to say, okay, this is 2.5, so I can't have half an atom, and that's not a rounding error. That's a pretty big gap. So what I'm going to go ahead and do is times everybody by 2. That way it gets rid of my half. It gets a little bit trickier if you get ratios like 7/3 and something like that. But it's still the same process. You look at your ratios to try and find the smallest whole number ratio that's going to get you something that's nice and clean. Obviously, if it's getting close like this guy, you just round it. It's probably just an imperfection in the data, and that's fine. So I'm going to say, you know what, this is probably 2.5. I can't have a half, so I'm going to multiply it by 2. So that 2.5 becomes 5, but I can't just multiply it. I'm going to multiply absolutely everybody by 2. So my 7 becomes a 14, my 9 becomes an 18, my 1 becomes a 2, and this guy becomes a 5. So I now have C14H18N2O5. Straightforward, a couple little quirks to this, but definitely something you can do. With that said, have a wonderful day.